The issue then becomes, can we precisely determine who will have the side effects if they receive a certain estrogen? Avoid, not give those people that, but the others may benefit from. Okay, selective therapeutics is going to be key. Now, just to extend that a little further, do you know that there is a field of performance genetics that the training centers, the national training centers, particularly in places like Australia, where they really put a lot of focus on this, starts trying to understand the physiologic, molecular, and genetic basis of performance. So things like the heat dissipation becomes a huge factor, and that there are certain devices that if you stick your hand in with negative pressure and cooling, you drop your core temperature upon exercise, and you increase the exercise tolerance, and you increase your capacity. That means you can actually work more, you can exercise more without the type of damage that might take place. So you enhance your capacity by this enhanced exercising that takes place, allowable by an adjunctive measure. So back to this whole thing that as we progressively get more targeted therapeutics, these estrogens that are highly, highly specific. And they're specific because we understand all the details of molecularly of how this thing works. We all hope that we will be able to be more precise in providing the best targeted positive benefits, minimizing the lower side effects, the bad side effects, and provide the cocktail that would prolong how you look so attractive now.
Any of the panelists would like to add anything?
I just want to add that the issue of aging, looking young, is centered around the concept of aging. And actually, that as a concept is something which scientists are trying very hard to define still, because we use the figure of age.
It's on. It's going to turn it towards
Closer to your.
Okay. So, can you hear me now? Yeah. So we're talking about aging when we are actually specifically talking about how we were younger. But aging is many processes. There are different parts of the body involved in wear and tear. So, for example, the calorie intake can affect the lifespan, and you can. Aging is not only just living longer, but also how you feel, the energy level. So there are many aspects of aging, and one of the issues is how can you obtain models to study aging. For example, a single gene mutation in the Progeria, for example, in that case, we can have a human being which age in a relatively short time become like an old man in 5 or 6 years. So that is from a single genetic defect. So the whole process of aging is accelerated. So there's clearly a lot of genetic components when we talk about aging. And so the target genes and the medicine we're talking about, which target prevention of aging, is probably a very complex network of the targets for aging.
Thank you, Bing. Anyone else in the audience? Yes, I think Trisha?
Yeah, hi, Tanya from the Straits Times. Even picking up on the whole news thing, how far do you think we are in terms of research to get the... Can you hear me?
Yeah, I can hear you.
Yeah. How
Others
far
may
are we?
not.
How many years do you think the research is away from reaching this point where we can, like, so-called stunt old aging and everything?
We're already doing it. Okay, but like all scientific discovery and all interventions, there's never a time where you didn't have it and all of a sudden you have it. It's an asymptotic phenomenon. Okay, you're just progressively getting better and better. A great example is the statins for your cholesterol. There's a natural variation of cholesterol in the populations that are both dietary but highly genetically predetermined. It's a complex mix of many different genes. What the statins do is to shift the curve so that for those who have, like myself, a predisposition for having high cholesterol, even if I starve myself, I still have higher cholesterol than somebody else. That drug allows me to have a cholesterol level that is considered optimum. And there is actually a family in Italy, there's actually a village in Italy where there's a family where individuals have actually surprising levels of cholesterol, but they live forever. They never have heart attacks. And it was found that one of their molecules that transport cholesterol is mutant. It's actually a positive mutation. And that's now being engineered as a therapy, potentially to reduce coronary artery constriction. And again, it's being experimented. Did you know that in Finland, there was a family that was a collection of 5,000-meter champions, won Olympic gold and what have you. It turns out they have a mutation in the erythropoietin gene, so that they have actually higher hematocrits. They're actually naturally doping. You know, the blood doping problem. They have naturally genetic doping. So the issue here is that as we progressively learn about these details, we will asymptotically achieve a better lifestyle. And asymptotically because these processes like aging is multi-genetic and multifactorial, and we're going to have to build all the parameters to actually control it.
I would like to make a little footnote to that. We age because our cells age. From the engineering point of view, I know mechanical engineers who think you can study aging by studying the attrition of material. But we age because the cells age. These are the ones doing all the maintenance. That's the interesting thing. A bridge will never repair itself. The human body can. But there's always a snag, and I'm the one today, I think, who always say there's no such a thing as a free lunch. We are doing it right now. The lifespan is accelerating. This has been driving pension systems into havoc because, well, I'm from Germany, so I can tell you, people have not expected that people would get that old. Now, what you now see is the older people get, the higher is their chance to develop a cancer. So this family, who is obviously so blessed and gets rid of the cholesterol by natural ways, I would love to have that mutation, is of course has a higher opportunity maybe than other people to develop to experience a cancer, but at old age, which also means that it's slow growing. So I just want to say there's always a price to pay. People are telling about cancer, and it's always very, very touching when talking about leukemia in children, but the real cancer killer is for the aging population. The older you get, the higher is the likelihood to develop cancer. So cancer, you could say, is a side effect of aging. So you would need to be able to also curb the propensity to develop tumors.
Okay, at the back, please.
I think I have a question for Professor Lai regarding intuition. I've read that highly accomplished spiritual leaders in various religions have very highly developed intuitive capabilities, especially in mind reading. So I'd like to know how that may factor into your future scientific investigations into intuition.
The quick answer is I have no answer. We at the Institute, we are electrical engineers and computer scientists by training. We're just beginning to look at how observing behaviors can help us determine mental attitudes, and clearly we will have to do so with the help of psychologists, and maybe doctors and psychiatrists and so on.